Hi, I'm John and welcome to my new channel where we're going to be discussing electrical, electronic principles and science. I'm an avid engineer and love science, and I thought if I can share some things with you, it may help you in some of your school, college or even just general interests. Anyway, what we're going to look at today is very basic electric circuits, and here's one I've drawn out. This is a basic electrical circuit. And I want to look at three elements in there, which is the voltage or potential difference, the resistance of a circuit, and the current within a circuit. If you notice this symbol here, that's the symbol for a battery. If you just had one of those, a pair of those lines, that would be a cell. This here is a variable resistor, so a normal square is a resistor and a square with an arrow through it is a variable resistor. So what we want to do is we're going to finally construct this in the next video and look at how these things interact. Anyway, but first of all, let's try and discuss what voltage is, what current is, and what resistance actually is, because we've all heard of these terms before, but what actually are they? So first of all, let's discuss electrical current. So electric current is actually a flow of electrons. So what we're going to do first of all is go back down onto a minute level and have a look at some atomic structure. So first of all, on an atomic level, in the center of an atom, you've got a nucleus. And inside the nucleus, you have particles called protons, which are positively charged, and you also have neutrons, and neutrons carry no charge. And flying around the outside of the atoms in various energy levels called shells, you have electrons. And electrons carry a negative charge. Now, the number of protons is the same number of electrons, so there's no actual overall charge on the atom, so the atoms don't carry any charge. Mother Nature doesn't actually like charges. Now, these shells, these are all actually, some of them are full and some of them are partially full of electrons. So what is we talk about current as being electron flow. So what is that exactly? Now, we know we've got electrons flying around the atom, but how do we get that to flow in a circuit? And what happens is, with certain materials, and metals are a very good example, that the outer shell, or valence shell as it's called, is not actually full of electrons. So the electrons are quite easily detached, and they do actually jump around. So if we get a group of atoms, like this, and these could be copper atoms, they're non-specific. And all I've shown on this at the moment is the actual valence shell, which is the outer shell and with one electron in it. So that it could be copper there because the outer shell in copper does only hold one electron. There are more energy shells in there which are actually full of electrons, but for the purposes of this demonstration, we're going to consider just the outside shell. And so this electron is very easily detached, and ordinarily, if there's no voltage across the circuit, these electrons are jumping around from atom to atom just to their own accord. But as soon as we put a voltage into the circuit, what happens is, if you can see this copper atom here, I've left the electron out. So that's jumped onto the next atom. And what happens is then this electron will jump onto that atom, leaving a gap there, which is called a hole. And so effectively, without that electron, that atom is now charged positive because the electron's negative. So this then electron will jump into that position, and then this electron will jump into that position. And that's how electron flow is generated in a circuit. And that electron flow is called the electrical current. So, what is the difference between electrical current and electrical voltage? Well, voltage is actually the electrical pressure. It's how hard these electrons are being pushed. So you could compare it to a tank of water. If you had a tank of water on the floor connected to a pipe, then there'd be very little flow in the pipe. But if you raise the tank in the air, that would cause the water to flow a little bit faster in the pipe, or with a little bit more pressure. And voltage works in exactly the same way. If you increase the voltage, for example, from 3 volts to 9 volts, then you'll have more electrical pressure, which is a greater push. Like in your house, you have 230 volts, which is quite an awful lot of push for electrons, and that's why people can get electric shocks in their house. While you won't get an electric shock off a battery in your normal car, because that's 12 volts and doesn't have the amount of push that your house does. So voltage is your electrical push or electrical pressure or potential difference, and current is the actual flow of electrons within the copper wire. So these atoms are like copper atoms, and the electron is bouncing down your copper wire. So that's the difference between current and voltage. So now, what about resistance then? So our resistance then here, as we can see that part of the circuit, if you think about the pipe and the tank that we just discussed, you raise the tank in the air, increasing the voltage, so it increases the flow of water in the pipe, the water being the current. Then if you pinch that pipe, then you get the resistance. That's the opposition to the electron flow. So if you pinch the pipe, that makes the water flow a little bit more difficult, and it drops the water flow. Resistance has the same effect in an electrical circuit. So if you have an increased resistance, then you impede the flow of electrons. So it drops the current. You increase resistance, you get a lower current. You increase the voltage or the electrical push, and you increase the current. Now what I wanted to discuss on here as well, if you notice, you've got a voltmeter there. Voltmeters are always connected in parallel. So you connect your voltmeter across where you want to measure the voltage. And here's your ammeter for your current. And you connect your ammeter into the circuit. So you want your current running through your ammeter. So your ammeter is a very low resistance or impedance, so it doesn't affect the current. And your voltmeter has a very high resistance or high impedance, which you can connect onto your circuit, and it won't short circuit or anything to that effect. We've had a look at a few elements of the electrical circuit. We've had a look at some current, some voltage, and some resistance. So what are the units they're measured in? Now, we call them SI units. Now, SI comes from System International de Units. And what this was about, in the 1960s, it was decided to standardize engineering quantities, because people were using different quantities. They could have been using inches, feet, meters, arm lengths, goodness knows what all. So they decided in a conference in France, a conference of weights and measures in 1960, on everybody using the same to prevent any confusion. So it was called this. So the units are called the System International de Units, or SI for short. And the SI units are in the circuit that we are concerned with are thus. So the SI unit for current is the ampere, and the symbol we use is A. The SI unit for electrical pressure or potential difference is the volt. We also call it voltage, and we use the symbol V. And the SI unit of resistance is called the ohm, with the symbol capital omega. So these things are very, very important. You remember, electrical quantity is current measured in amps. Electrical voltage or potential difference is measured in volts, V, and resistance is measured in ohms, symbol omega. What we're going to do in the next film is actually construct the circuit that we looked at earlier and see how these quantities affect each other, and to see if we can put some kind of law together that explains how these quantities relate to each other. And what we're going to do in part 2, as I said, is construct this circuit and see how they all connect together. Please subscribe to the channel if you wish, and if you want me to cover anything specifically that you're having problems with, if I can help you with, or just you're curious about, can't promise I'll be able to do it, but I will certainly do my best to try and help you out, because this is what it's all about, sharing of knowledge. So let me know in the comments if you want me to do anything, and I'll see you in part 2.